Assalamu alaikum, dear students. Our today's topic is for class 12th, subject physics. In the previous lectures, we have discussed number of topics of the unit electrostatics. Now today we'll derive some numerical problems which are from the NCERT textbook. Very first numerical is 4-point charges, QA equal to 2 microcoulombs, QB equal to minus 5 microcoulombs, QC equal to 2 microcoulombs, and QD equal to minus 5 microcoulombs located at the corners of a square ABCD of side 10 centimeter. What is the force on a charge of 1 microcoulomb placed at the center of the square? So four charges are given here, but these four charges are located at the corners of a square, such as QA is equal to 2 microcoulombs, means charge on the corner A, that's 2 microcoulombs. Similarly, charge on corner B, QB, that is equal to QB, that is minus 5 microcoulombs, Similarly, charge on corner C, QC, that is equal to 2 microcoulombs. We have charge on corner D, that is QD, that is minus 5 microcoulombs. Now a charge of 1 microcoulomb is placed at the center of the sphere. So here, center O, a charge equal to 1 microcoulomb. Now we have to calculate the net force acting on this charge due to all other charges. So we'll solve it. So we have to calculate what is the force on a charge of 1 microcoulomb placed at the center of a square. So we have ABCD is a square. ABCD is a square having two diagonals of side. ABCD is a square of side 10 centimeter. आप देख रहे हैं कि we know that the sides of a square they are equal. So each side is 10 centimeters. We write here 10, 10. So it is also 10 here. It is 10 centimeter. Now here AC and BD are the two diagonals. We'll write here AC and BD are two diagonals of a square ABCD. So these are the two diagonals of a square. So first of all, we'll take this diagonal AC. So this AC, we can write here. Therefore, we can write, if AC is the diagonal, आप देख रहे हैं यहाँ पर कि if AC is the diagonal, then we can write OA, that is equal to half of AC. You can write here OA, that is equal to 1 divided by 2 AC. Now we have to calculate this AC. What is this AC? Now we have a right angle triangle here. ABC is a right angle triangle. Then we have hypotenuse, base as well as perpendicular. So we know that by Pythagoras theorem, we have hypotenuse square h square is equal to base square plus perpendicular square. So hypotenuse, it's the hypotenuse, that's AC. So AC square is equal to base, that is 10 square, plus perpendicular, that's also 10 square. It is 10 square. So we can write here AC square is equal to, so it will be twice into 10 square, or we can write here AC is equal to under root of 2 into 10 square. 2 into 10 square. Similarly, we will write here OA is equal to 1 divided by 2 AC. So AC is under root of 2 into 10 square. So square and root will cancel to each other. We can write here AC is equal to 1 divided by 2 under root 2 into 10. So we write here, so this will be 5. Okay. OA is equal to 1. OA is equal to OA, that is equal to, so this will be 5 under root 2. 5 under root 2. Or we can write in this way, OA is equal to 5 under root 2. We will multiply here root 2 and divide by root 2. Or we can write here OA is equal to, so this will be equal to 5 under root 2 whole square divided by under root 2. divided by under root 2. So this root will cancel. So we can write here 5. So it will be 10, or we can write here OA. It is OA. OA. OA is equal to, so this will be 10 divided by under root 2 centimeters, because the side of a square is 10 centimeters, so it's in centimeters. But we have to write it into meters. We have to convert it into SI system. So we'll write here OA is equal to 10 divided by root 2 into 10 raised to power minus 2 meters. So this is OA. Now we can easily calculate the force between these two charges. तो हमारे पास दो चार्जेस है. We have Q A and Q, and the separation between the charge हमारे पास distance भी है. तो आप easily निकाल सकते हैं यहाँ पर force between these two charges. Basically, we have to calculate the total force, net force, which acts on this charge, due to all other charges. So we'll calculate one by one. So we have a pair here, QA and Q. So we'll calculate the force between these two charges. First of all, we'll calculate the force between these two charges, and then force between these two charges, then force between these two charges, and then force between these two charges. Then we will see what is the total force which acts on this charge due to all other charges which are placed at the corners of a square. So first of all, we'll calculate here force between force on Q, means force on this charge due to QA, due to QA. So that we write it as F1, magnitude of F1. So the magnitude of force between the two charges, so that is equal to, we will apply the Coulomb's law. We know that according to Coulomb's law, if I have 2-point charges and the force between 2-point charges, that is directly proportional to the product of their magnitudes, product of magnitude of their charges, and inversely proportional to the square of the distance between them. So we'll write here 1 divided by 4 pi epsilon naught. This according to Coulomb's law. Q1. So here we have Q1, that's 2 microcoulombs. 2 microcoulombs into Q2, that's 1 microcoulomb, and divided by the square of distance between them. So square of distance between them, that's OA. So OA हमने निकाला है, that is 10 divided by under root 2 into 10 raised to power minus 2 meters, into 10 raised to power minus 2 meters. So right here 10 raised to power, or we can write here the magnitude of force F1, that is equal to 1 divided by 4 pi epsilon naught, 1 divided by 4 pi epsilon naught. Here it is 2 microcoulombs. 2 into 1 microcoulomb is that is 10 raised to power minus 6 coulombs. So we'll write here 10 raised to power minus 6 coulombs into, so 1 microcoulomb, that's 10 raised to power minus 6 coulombs divided by here it is 10 divided by under root 2 into 10 raised to power minus 2. So but it is square of the distance. So we write it as square here. So it is square of the distance. So we have already calculated this. So it is magnitude of force F1, that is equal to, so this is 9 into 10 raised to power 9. So it is 1 divided by 4 pi epsilon naught is the constant. So that's 9 into 10 raised to power 9 into 2 into 10 raised to power minus 12 divided by, so here this will be, so it will be 100 square है यहाँ पर, divided by under root 2 square into, so this will be 10 raised to power minus 4, 10 raised to power minus 4. So this 2 and root will cancel to each other. So we can write here, so we'll write here the magnitude of force F1, that is equal to, so this will be 9 2s are, so it will be 18 into 10 raised to power, so here it will be minus 3 divided by, so here it will be 50. So we can write here 50 into 10 raised to power minus 4, 10 raised to power minus 4, or we can write here the force F1, the magnitude of force between these 2 point charges, that is equal to, so this will be 18 into 10 raised to power minus 3, or divided by, so I can write in this way, into 10 into 10 into, so here it will be 10 raised to power 4, or we can write the magnitude of force F1, that is equal to, so this will be 18 into 10 divided by 5 into 10. So 10 or 10 will cancel. So a magnitude of force F1, that is equal to 18 divided by 5. So this will be 3 points. So it will be 6. It will be 6. Yes, it will be 6. So magnitude of force F1, that is equal to 3.6. So ये हमें निकला force between these two charges. So here it is the force of repulsion 3.6. Now second, we will calculate the force between these 2 point charges, these two charges. So here we have 2 microcoulombs, here it's 1 microcoulomb. इनके दरमियान हम देखेंगे what is the force. What is the force? So next, we will calculate the force acting on this charge Q due to charge QC. Force on charge Q due to QC. Due to QC. So according to Coulomb's law, we will apply the Coulomb's law here. So magnitude of force. So here it will be F2, that is equal to 9 into 10 raised to power 9 into, so Q1. So here it is 2 microcoulombs into, so it is 1 microcoulomb divided by the square of the distance. So here it is the center of the circle, it's the center of the square. OA is equal to OC. So that means here square of the distance जो है, that's OC. So we can write here OC square, but OC, that's equal to OA. We have already calculated OA, that is 10 divided by 2 into 10 raised to power minus 2 under root. So it is under root 10 divided by root 2. So it's 10 divided by root 2 here. It is 10 divided by, so it's 10 divided by root 2 into 10 raised to power minus 2. So we'll write here F2. So magnitude of F2, that is equal to, so magnitude of force, that F2 means the force which acts on this charge Q due to this QC. So that will be represented by F2, the magnitude of force F2, that is equal to 9 into 10 raised to power 9 into 2 into 10 raised to power minus 6 into 10 raised to power minus 6 divided by, so here it will be 10 divided by under root 2 into 10 raised to power minus 2 whole square. Or we can write here F2, that is equal to, so it will be 9 into 10 raised to power 9 into 2 into 10 raised to power minus 12 divided by, so here it will be 100 divided by under root 2 whole square. So square root cancel into 10 raised to power minus 4 into 10 raised to power minus 4. So this will be here magnitude of force F2, that is equal to, so it will be 18 into 10 raised to power, so it will be 10 raised to power minus 3 divided by, so this will be 50 So we can write here 50 into 10 raised to power minus 4. 10 raised to power minus 4. Or we can write here magnitude of force F2, that is equal to, so this is 18 into 10 raised to power minus 3 into 10 raised to power 4 divided by 50. Or we can write here F2, magnitude of force F2, that is equal to, so here it will be, uh, 18 into 10 divided by 5 into 10. So this will cancel each other. So F2, that is equal to 3.6. So it is again 3.6. So that means F1 is equal to, so F1, magnitude of F1 is equal to magnitude of force F2. Magnitude of force F2. So here, but the direction is opposite. We have same. तो यहाँ पर आप देखेंगे, so F1 is equal to F2. That means the magnitude of the force, that's equal to each other, but the direction is opposite. We can say here. So this force, the direction of force is from Q2 towards Q1. Here the direction of force is from Q2 towards Q. So direction of force, the direction of force here, the direction of force will be from QA to Q, and here, so that will be in this direction. So here the direction of force will be from QC to Q. So direction will be in this direction. So that means the both the force will cancel to each other. The net force on Q due to QA and Q2, so that will be equal to 0. That will be equal to 0 because the magnitude is equal, but the direction of force, that is opposite to each other. So the net force at this point, that will be 0. So we write here net force on Q due to QA and QC is 0. So that is 0. It will be 0 here. It will be 0. Now, next we will calculate, we will derive the force acting on. So the force on Q due to QB as well as the force on Q due to QD. तो ये दो हम निकालेंगे पहले. So we'll derive these two. The next हम निकालेंगे force on Q due to QB. Force on Q due to QB. Here, so we'll write that F3, that will be F3, the magnitude of force. So the magnitude of force, the force between QB and Q. So that we write it as F3, that is equal to, according to Coulomb's law, 1 divided by 4 pi epsilon naught Q1. So Q1 here, it is 5 microcoulombs into Q2, that's 1 microcoulomb divided by the distance between. Here, O is the center, so OA, that is equal to this OB. So we can write it as 10 divided by under root 2 into 10 raised to power minus 2 centimeters, meters. Okay, so it's meters. So we can write here F3 is equal to, so this will be 9 into, we know that this 9, 1 divided by 4 pi epsilon naught, this is 9 into 10 raised to power 9 into 5 into 1 microcoulomb. So we have to change into coulombs. So that is 10 raised to power minus 6 coulombs into 10 raised to power minus 6 coulombs divided by, so here it is square of the distance. So this will be 100. If we take the square of this, divided by 2 into 10 raised to power minus 4. Or we can write, so this is 50. So magnitude of the force F3 is equal to, so 9 into 10 raised to power 9 into 5 into 10 raised to power minus 12. So this will be 10 raised to power minus 12 divided by, so it is divided by, so this will be 50 into 10 raised to power minus 4. 10 raised to power minus 4. Or we can write F3, magnitude of force F3 is equal to, so this will be 45 into 10 raised to power minus 3 divided by 50. It's 50 here. 50 into 10 raised to power minus 4. Or we can write here magnitude of force F3. Magnitude of force F3, that magnitude of force F3, that is equal to, so here it will be 45 into 10 raised to power minus 3 into 10 raised to power 4 divided by 5 into 10. So here it will be written as, or we can write here magnitude of force F3 equal to 45 into, so this will be 10 divided by 5 into 10. So 10 or 10 will cancel to each other. So this will cancel to each other. So we can write here F3 is equal to, so this is 9. So this will be 9 newtons. 9 newtons. So आप देख रहे हैं यहाँ पर force of QB on QA or force of QB on Q. So that is 9 newtons. So it is 9 newtons. Now similarly, if we will calculate the force on Q due to QD, due to QD, so this will also be equal to 9 newtons, because here it was 5 microcoulombs, it was 1 microcoulomb. Now here it is 5 microcoulomb and it's 1 microcoulomb, और इनके दरमियान जो distance है that is same, so the force will be same. So here similarly we can write here similarly F3, magnitude of F4, that will be equal to, so the magnitude of 4 that indicates that the force on charge Q due to QD, so that will also be equal to 9 newtons. So it will 9 newtons. So here if we see the net force, if you see the net force on the charge due to QB and QD, the net force on the charge Q due to QC, it is due to QC and QD, due to QC and QD, so that will also be equal to 0. So that will be equal to 0, because here we have F3, that's the force on charge Q due to QB, that's 9 newtons. Similarly, the force on charge Q due to QD, that's also equal to 9 newtons. 9 newtons. Both the forces are equal in magnitude, but they are opposite in direction. So अगर आप यहाँ से देखेंगे, so the force will be in this direction. So यहाँ से अगर आप देखेंगे force will be in this direction. So both have same magnitude. यहाँ से भी same magnitude होगा, यहाँ से भी, but opposite in direction. So net force will be 0. So net force is equal to 0. But we have to calculate the total force, net force or resultant force acting on this charge due to all other charges which are located at the corners of the sphere. Resultant force, total force on Q due to QA, QB, QC and QD. So net force that will also be equal to 0. Here the force on charge Q due to these two charges A and C, that is 0. Similarly, the force on Q due to these two charges B and D, that's equal to 0. So the net charge will be equal to 0. So that is equal to 0. That is equal to 0. So it was our first numerical. Our second numerical. That is what is the force between force between two small charged spheres having charges 2 into 10 raised to power minus 7, 2 into 10 raised to power minus 7 coulombs, 2 into 10 raised to power minus 7 coulombs, and 3 into 10 raised to power minus 7 coulombs separated placed 30 centimeters apart in air, placed 30 centimeters apart in air. So it's very simple numerical. So what is the force between the two small charged spheres having charge 2 into 10 raised to power minus 7, 3 into 10 raised to power minus 7, placed 30 centimeters apart in air? So we have two charges here. Q1, that is equal to 2 into 10 raised to power minus 7 coulombs, and Q2, that is equal to 3 into 10 raised to power minus 7 coulombs, 3 into 10 raised to power minus 7 coulombs. And the distance, so distance is r, that is equal to 30 centimeters. So we have to change it into meters, so we can write it as so this will be equal to 0.3 meters when we change it into meters. So we have to calculate the force between the two charged spheres. So we'll apply the Coulomb's law. So we can write here F is equal to 1 divided by 4 pi epsilon naught Q1. So Q1 is here Q1 is 2 into 10 raised to power minus 7 into 3 into 10 raised to power minus 7 divided by, so this will be 0.3 whole square, or we can write here F, that is equal to, so this will be 9 into 10 raised to power 9 into, so this will be 6 into 10 raised to power minus 14 divided by, so this will be 3, so this will be 3, or we can write in this way 0.3 into 0.3. So F is equal to, so this will be 54 into 10 raised to power, so this will be 10 raised to power minus 4, so it's 10 raised to power minus 4. Oh, 10 raised to power minus 5. So it will be 10 raised to power minus 5. 10 raised to power minus 5 divided by. So here it will be, yes, it will be 9 into 10 raised to power minus 2. Yes, it will be 9 into 10 raised to power minus 2. Okay. So it will be 3 divided by 10, 3 divided by 10. So this will be 9, 10 raised to power minus 2. Okay. So we can write here force is equal to 6. So this will be 6 into 10 raised to power minus 5 into 10 raised to power minus, it will be plus 2. Or we can write here force is equal to 6 into 10 raised to power minus 3 newtons. So another numerical.